back. Today we are going to discuss about quantum communication. Now, what is quantum communication? So, quantum communication is nothing but sending information using quantum particles. What are the quantum particles? Quantum particles are nothing but we'll be using photons. What is that? Photons. In quantum communication, photons are nothing but particles of light energy or packets of light energy instead of normal electrical signals. Normal electrical signals. We are using normal electrical signals in classical computers. Okay. But whereas in quantum computers, we'll be using photons to transmit the data. Now moving on to one more slide, that is nothing but how this quantum communication has been evolving from the past. So in early 1970s and 1980s, scientists first started thinking. So what they have thought and what they started thinking are nothing but what if we use the strange behavior of quantum particles to send messages securely. So they started thinking, why can't we use these quantum particles to send messages? So from there, they learned that particles like photons could exist in special states called superposition and entanglement. Okay, these ideas were the foundation of quantum communication. So the main goal is very simple. The main goal is to find a way to make communication that no one could hack. That is the agenda of quantum communication. Now in 1990s, so early 1970s and 1980s, just thought what if, but whereas in 1990s they started experiments and finally proved that photons could carry the information, and researchers used polarized light vibrating in different directions to represent qubits, that is nothing but 0 or 1. They could send these photons safely between two places. Then in 2000s, the things got more practical. We got optical fiber and free space quantum links. That means light could travel through cables or even through open air to connect distant labs. So quantum communication moved from just theory to real experiment. That is nothing but from 1970s to 2000s. So things have been changed. Okay. Now moving on to the definition of quantum communication. So quantum communication uses quantum particles like photons to send information instead of normal electrical signals. In normal communication, we send bits, but in quantum communication we send qubits, which can be both 0 and 1 at once. That is nothing but superposition. So the superposition is written as ket psi is equal to alpha ket 0 plus beta ket 1, where alpha and beta are nothing but the complex numbers. Yes or no? Now here alpha and beta are nothing but complex number that I already mentioned. The symbol alpha and beta show the probabilities of the qubit being 0 or 1. So together they should satisfy mod alpha square plus mod beta square should be equal to 1. That is nothing but normalization. Because of quantum mechanics, the qubit keeps both possibilities until it's measured. Once you measure it, it will collapse to either 0 or 1. That is nothing but classical state. Yes or no? So the key idea here is a photon or electron can carry a secret quantum state. So if anyone is trying to look, or if anyone trying to hack the system, that changes instantly because measurement collapses the information, or measurement collapses the superposition. So there is no chance for hacking. That was the key idea here. So now in simple terms, we can say quantum communication is like nature's own lock and key. No one can open that lock. No one can lock that lock. Okay. It keeps information safe automatically, because touching it changes. If anyone is touching, or even if anyone is trying to measure it, it changes automatically. That means any hacker or spy can detect it instantly. So this idea led us to the quantum internet. From here we are entering to one more concept, that is nothing but quantum internet, where messages and data can be shared securely, faster and smarter than even before. Okay. Now we are having some key properties. I think you already know all those properties. So the first one is nothing but a superposition. A qubit can represent many possibilities at once. We call it as superposition. The second one is nothing but entanglement. Entanglement. What is entanglement? Two particles can be linked. Two or more particles can be linked. Changing one determines the state of another particle instantly, even they are far apart, even they are across large distances. So third one is nothing but no cloning theorem. You can't make a perfect copy of unknown quantum state. So last one is nothing but measurement. When you measure a qubit, you disturb it. So spying cannot be hidden. So these rules make it unhackable by design. So securely guaranteed by physics, not the passwords. So this is impossible to hack. That is why we require quantum communication. Now I have explained this in diagram. So if you look here, Alice prepares quantum states, that is nothing but a message, wants to send to Bob, and it will be using photons. They will be using photons to carry the message. So these message will travel through the quantum channel. This is the quantum channel, that is nothing but optical fiber or anything it may be. So if Eve wants to hack, for example, he wants to hack, okay, or try to copy the photons, but if Eve tries to touch the information, their state changes, alerting the both ends. Bob and Alice gets the message that someone is eyeing, so the state is changed. Now after going that particular information to Bob detects and measures the photon using quantum state detection. So this message is being detected using quantum state detection. And finally, now they need to know whether the information that Alice sent to Bob is correct or not. They will be using authenticated classical channel. So this is nothing but a normal line to confirm that no one is interfere. For example, Alice wants to send plus and Bob also received plus. They will authenticate, or they will communicate using this classical channel, that Alice says that I have sent plus message and Bob also says that I have received the plus. Then we will proceed. If anyone is trying in between, so the state changes into for example, if that change, if here it is plus, if anyone tries to hack, the state has been changed and it became hex. So Bob says that I have received x, but Alice says that I have sent plus. So there is a miscommunication, right? So something is happening in middle. So then they stop sending the message through quantum channel. Okay, they update the quantum system that someone is eyeing on our system. So our basis got changed. So we need to stop the information passing through the quantum channel. So that is why quantum security will be there in quantum communication. Now moving on to the present applications of quantum communication. So satellites and fiber networks can send quantum signals across thousands of kilometers, that you need to remember. Devices called quantum repeaters and quantum memories help extend the distance even further. For example, I as of now it is like 1,000 kilometer distance we can send a photon, but using quantum repeaters we can extend it. We using quantum memories, we can extend it until up to 1,000 kilometers. That is the use of quantum repeaters. So scientists are also testing quantum teleportation and moving quantum information instantly. Okay, they are testing quantum teleportation as of now. So it's already being used in government and defense and even banking sectors for secure data transmission. So the big dream is nothing but quantum internet. This will connect quantum computers and devices using entanglement instead of normal data cables. It allow instant and secure communication. Remote quantum computing and quantum cloud services will be the emerging techniques. So quantum cloud services where companies or researchers can use quantum power safely online. So that is why we require quantum cloud services. So the quantum internet will change how information move across the planet faster, safer and smarter. So the last slide. Okay. So the future goes even further. So quantum information will enable ultra precise timing using quantum clocks. Ultra precise timing using quantum clocks. Quantum sensing for navigation and space research. Networks that can never be hacked because any institution changes the quantum states. In short, we can say quantum communication is growing from classroom idea to real time experiments to the global network that may soon link the entire world. So that is what about quantum communication. So thank you guys. If you are having any doubts, let me know in the comment section.